I told you that in next 30 minutes, you will understand exactly how to build an AI assistant that reads your email, manages your calendar, and remembers your preferences, all by writing code you can actually follow.
And the best part, you don't need a PhD in machine learning. If you know the basic TypeScript, you are good to go. Welcome back to AI Agents Demystified. I'm Shrija.
I'm Rafi. And if you have watched episode 1, you already know what AI agent is and how autonomy works. The idea that AI agent can observe, think, and act on its own.
Right. And in episode 1, we talked a lot about theory. What does it actually look like in code? We are going to explore in this episode.
That's exactly what we are going to do today. We are going to open up a real project, a personal assistant that I built, and I walk through every layer line by line.
So by the end of this episode, if someone pauses the video and opens their code editor, they could actually start building something like this. Right, Rafi?
Absolutely. Absolutely. All the code is on genai-mentor GitHub repo. So you can also refer that code by checking out by yourself. Most importantly, you will understand the patterns because once you know how it works, you can build any kind of agent, a customer support agent, a research assistant agent. The architecture is the same.
That's amazing. So where do we start?
Let me explain a big picture so that you can get that context yourself, and then we can walk through the journey. Let me tell you a story, a quick story.
I'm all
Every
yours.
yeah. So every morning I wake up, I check my email, look at my calendar, maybe search for the documents I need to work on or needed for the meeting. So that takes 15 minutes of context switching between apps. I thought if I would have an assistant with an interface where I can type a few prompts, what's happening today, and it does everything for me, and I get the gist out of it with all the necessary documents and the email scheduled, etc. That may be handy. It can save me 15 minutes.
So instead of you going to Gmail and then to Google Calendar and then to Google Drive separately, is it?
Exactly. The AI agent does it for me. So I talk like a human assistant and it figures out what tools to use behind the scenes.
That sounds amazing. So how can you just give an overview? What is the tech stack that we need to have that?
The architecture view that I just displayed. So it has a few layers. Okay. The first layer is the user interface, which is a chat interface built in React frontend in TypeScript, which is running in Next.js, uh, which will call the APIs, the backend APIs, which are running, which can be run in serverless functions. It could be run in Firebase Cloud, etc. So that will run the agentic core. So in Anthropic Cloud SDK, which can have an orchestrator, a personal assistant orchestrator, which can call multiple tools, whether it is a Gmail or calendar or Drive, and putting all together, constructing an AI agent. And anything needed that need to be persisted that can be stored in the Firebase database as a database layer, whether it is a conversation or memory or configuration.
Yeah, the layers look clear, but can you explain how it orchestrates to make it work?
Yeah, so that is the core part, AI orchestration. So that has specialized tools. For example, for each capability, you need to have tools enabled. For example, Gmail uh, tools could be enabling a Gmail specialist to read, write emails. Uh, Scheduling specialist can call calendar tools, and document specialist can read the documents from Google Drive. And the recall specialist is a memory that can save and retrieve the memory. So that four specialist agents, specialization tools will be available. An AI orchestrator can decide when to call which specialist to work on. and finally get the job done.
So the AI model is like the manager and the tools are like the team members, is it?
Exactly. So you are getting the picture now. So the beauty is the Claude say it doesn't call one tool and stop. Okay, it can call multiple tools as and when it is needed. So that is the orchestrator that I explained. So orchestrator is kind of manager, as you told, and it can realize and make it happen through the specialist with Gmail specialist, scheduling specialist, or document specialist, etc.
So that does sound like an agent loop that we talked about in episode 1, is it?
Exactly. So let's see that in the code. We'll explain one by one here.
Before we deep dive into the code, Rafi, can you just walk us through how the project is organized? Because I think that will help a lot of people to know where to actually look when they look at the code.
Exactly. Let me share my screen. Yeah. Okay, so I'll explain the project structure first. Okay, so this is the project. Personal assistant is the project. Okay, so now the project structure, I have SRC folder which has app, which is the front end code, which has multiple components, login, etc. And it has a library which is having agent prompts, tools, etc. And Firebase for the database and configuration for storing the configuration, memory, etc., which will deep dive one by one. And the second component in the code base is the functions, which is the backend code, which is going to run in the function. So these are the two main components in the code base, and all of this code will be available for you in a GitHub repo, which you can find in our genai-mentor webpage.
I can basically relate to what we saw in the previous episode's diagram, right? The memory, the agent, the MCP tools, all I can see in this folder structure. So actually in this production, everything works through this cloud functions, is it?
Exactly. So you love front end and you love backend running in cloud functions.
Okay. I may be biased, but I'm very more interested in the brain component that we saw in the last episode, right? The agent core. Can you just show me the code that makes this AI agent to think?
Yeah. So now we have gone through the structure. So let's deep dive now. Okay, let me open SRC agents and index. Okay. So let's start with this. Okay, so this is about personal assistant agent. So the core part for agent is the brain is LLM. Okay, now let's find out where that LLM is integrated. Okay, here. So now for personal assistant, I'm saying that you use Anthropic and you use this configuration. So Anthropic client is used, and this config will have the models, which is nothing but your brain. So I'm using two models, one for reasoning and one for task. So for reasoning, you can use a good model. Say Opus is a good one for reasoning. Or if you want to, if you're cost conscious, you can use Sonnet, etc. And task model, you can pick up a model which cost lesser than the other models, because the reasoning model need to think. So you need to pick up a wise model. Task model, you are delegating a particular task. So it can be a model that can be less capable, but it is okay to do a task level. These are the LLMs which are configured for the agent to use that as a brain.
So an Anthropic configuration and the model configuration. That's it. So I was expecting
Exactly.
something much more complicated than this.
So that is the beauty of building on top of a powerful foundation model. So the intelligence is in Claude. So our job is to give the right context and the right tools. So we don't need to, we have to just leverage the large language model brain.
Yeah, that eases a lot of pain.
Now let me show you the chat method, which actually does that context engineering, the basically the core of the agentic core, how that the user message gets processed. Okay. So we looked at that brain, how it is wired.
Yeah.
Now this is the chat. Okay. So it takes the user message, which is the user prompt, and with the conversational ID to correlate, and the history of say last 10 messages in the conversation. We'll go the step by step. Okay, how does it conversation happens in the behind the scene? So it collects the memory, so which is one of the component in the autonomy of AI. So whether it is short-term memory or long-term memory, etc. Second, it's build the system prompt. So that is one of the component AI autonomy. We'll deep dive a little later in this session. Third one is the available tools. What are the available tools that are available for the capability? And putting together, you need to make a API call. So these are the three things that you need to make it ready before making API call.
Yeah, I understood the context now.
So now this context need to be engineered and API call need to happen.
Got it. So it's not just the user prompt alone. To make an AI agent more powerful, you need to engineer all of the components as we spoke in the autonomy of AI agent, right? To work as a personal assistant with the access to all the Gmail and drives and so on.
So now we make the API call. Okay. So now, so you got the context, right? So now you need to call the LLM. So you need to give all this context to the brain. So this is the first API call that you make. Initiate API call. So you're giving which model to use, and then what is the maximum token, what is the system prompt, what are the messages, and what are the tools, and you make the first API call. Okay, we send the system prompt. So you make the first API call.
So how do we know which one the model is choosing? Okay,
so now you are asking about the tool, right? I'm giving set of tools. Your question is which tool it is using, whether to send email or schedule meeting. So this is the first call. Okay, in the first call, it will tell a response and it will stop. It will not end up with one user, one LLM call. Okay, it will tell you, okay, I need to use a tool. So that is what will come in a stop reason tool use. So then that will have which tool to use. Okay, then you need to execute the tool and you get the result from the execution and you need to pass that, collect all the result in the tool result. Then you need to call the LLM again. Okay, I executed this tool and I got this response. And what you want me to do next?
This sounds like a loop.
Yeah, exactly. So this while loop, okay, so let me walk through this slowly. You executed one tool, you got the response and giving it to the LLM again. Okay, so for example, call Gmail API to get all the emails that are written already. If it tells again, go to Google Drive to fetch a document. When it gets all the tools executed that are needed, if it gets all the detail to summarize, it will come out of this loop. It will not stop for a reason for tool use. Then it will come out of this loop. Then you have all the context and tool execution. You can answer by summarizing it.
Got it. So it first extracts which tools the cloud wants to call. Then it actually executes those tools. It can be Gmail API or Calendar API, whatever. Then it collects the results and then it sends those results back to Claude as if the user said, here are your tool results, right? And then the Claude will look at the results and decides again, do I need another tool or can I answer now? And the loop keeps on going until the Claude says, okay, I have enough information. Here is my answer. So this is how the loop executes, right?
Exactly. And also one more thing I just want to point out. So when you execute a tool, you may end up in some error scenario. Even if the tool errors out, you need to tell, okay, the tool errored out, this is the reason, etc. So then you need to give that information also so that it can handle gracefully. If tool doesn't work, okay, it can give you the instructions so that you can manually send email.
Amazing. That's really elegant, no? So the Claude is genuinely making decisions in every loop. It is not just like a rule-based or a scripted workflow, right?
Right. That is the difference between the chatbot and AI agent. The chatbot is just is the input prompt and output prompt, but AI agent thinks and acts, reasons well, and what to do next, executes the tool, and then finally summarizes it for you.
That's brilliant. So we saw that the agent calls the tools, right? So let's see how these tools are actually defined in the code.
Yeah. So now we explained that the overall agentic core of the personal assistants. So now let's deep dive few components. Let's start with the tools. So let me go to the tools. Okay, this is the code tools and custom tools. Okay, so now there are certain tools needed for memory. Okay, so here you see the save memory and recall memory. So these are the two functions which are exposing some tools for saving memory and recalling memory. So this is these are the two functions or the tools that are getting exposed.
Okay, so when I see it, it's like literally telling Claude, hey, you have a tool called save memory. Here is what it does and what input it needs. Am I understanding that?
That exactly that is the key insight. So you need to have a name of the tool and description, which is very important. It's like a job description for that particular tool. So save memory tells save important information about the user for future reference, and it also tells the schema. Okay, what are the fields that are needed for input. So you need to give some string information to remember, and what is the type, is it preference or fact, and what is it required. Both are required, content also required, and type is also required. So it defines, it's basically the method definition kind of, it's a tool definition.
Got it. This does really sound like a job description. Hey, this is what you have to do. This is what your things are. And that brings me to the next question. Say, when I do the next conversation with it, or when the user says, schedule a meeting for me, will the agent be able to recall the preferences and suggest the morning slot if that person is a morning meeting kind of a person?
Correct. So now this is the definition of tool. Let me go to the execute tool call. So this execute tool call method is here. When you say I prefer morning meeting, it will call save memory, and it will put, okay, since you said prefer, it will put it in preference for the user, store preference. And
Okay.
when you have further conversation, it will use recall memory. So it will get all the memories, whether it is preference or fact, etc., so that that memory is used in the further conversation.
So it's basically like a router, is it? Claude says, I want to call save memory. Your code looks at the tool name and routes it to the right function.
Exactly. So we talked about save memory and recall memory. And also you see the routing capability if the function names matches to this, etc. But you also see the external tool calls, Gmail calls, Gmail send email, read email, etc. So then it goes to this execute MCP tools. So I'm calling a API based, but you can also use MCP and tools execution for external integration. So it's a router, as you mentioned. So it decides which tool to use and how to use it, kind of routes the tool to execute the right tool execution.
Got it. So what you're showing is the MCP tool definitions. In our case, it's Google services, right?
Correct. So in this personal assistant, I took Google features. One more thing I wanted to tell you: when you use tool, you need to make sure you are authenticated also. Otherwise, if the user is not willing to allow the tool to be used, so you need to check, okay, is it authenticated? Then you expose the tool.
For the permission for Claude to access
Correct.
that.
Correct.
Right? Okay. Okay.
Yeah. First you check the service is enabled, and second check is it authenticated. Then you register the tools for AI to use. Both
Got
check are
it.
important. Is it enabled and authenticated?
Yeah, that's a nice safety feature, no? And I also remember something like in Gmail send description, always confirm with the user before sending. So does Claude actually follow that? There are some times when I just try to send an email without even putting a subject or something like that. So can we have a safety feature like that into this one?
Yes, that's the beauty of system prompt. So eventually it's all English, right? So you need to give the behavioral details for all of that. So I think you rightly mentioned. Yeah. So here you see, I think you can give that instructions. Also, I'll show that in system prompt when we go to system prompt. So you can give the behavioral guidelines for each of that. If you want to check before sending email, whether it need to write professionally well, etc. All the guardrail you can give in the system prompt so that it will behave like that.
Yeah, that is a really great safety guardrail to have it for people like me. Okay, so we understood this one. Let us talk something about memory. Like in episode 1, we said that one of the key feature for a truly autonomous agent is that it can remember things across conversations, right? So how does that work here, Rafi?
Yeah, so the memory system, you need to always think AI agent with kind of comparing with human. So you need to design a multi-tier, three-tier memory system inspired by how human memory actually works. So you need to have short-term memory so that you can keep the last 10 conversation in the messages in the conversation in the session, so that your next message prompt is keep considering what you asked in last 10 conversation to use. That is short-term memory. The second is long-term memory. If you want to remember across the session, you need to persist in a database or some way of long-term memory. So I used as a Firebase. So the long-term memory persists that Firebase, so that it could be preference, it could be facts or instruction. You can put it a certain retention period, say 30 days, etc. And third is episodic memory. What does episodic memory means? So you will have conversation. You need to take a gist of the conversation and store it as a summarized chat conversation, so that you can use that. Okay, we discussed about autonomy of AI in one conversation. Second, we are also discussing the code detail of how to build agent. So the summary of that should be retained so that in next conversation, it will use that and contextually will respond well. So these are the three types of memory I would advise anybody to implement as a basic memory function.
Got it. So this sounds like a simple memory map for me. Short-term memory, long-term memory, and episodic memory. And what about the intent and entities fields, Rafi?
Yeah, so I'll take one example. Okay, let's take a prompt, user prompt, send an email to John about the project update. Okay, so that intent, that key, that word you need to kind of, you need to get that right. What is intent? Intent is nothing but the action that you need to do. In this case, send an email to John about project update. The main intent is send email. Okay, entities are about the object that is connected to the intent. Okay, the recipient is the John. We need to send email to John. So John is the entity, and about the topic. Okay, it's a project update. So you need to send email is an intent to John entity about the project update. Okay, these are the intent and entity which internally AI will detect, identify the intent based on the prompt, and identify the entities that it need to work on.
Oh, that's clever. So when the agent loads up memory, it groups it into categories and format. It's like a nice readable list for Claude.
Right. So this is the formatted context, goes straight to the system prompt. So every time I think, so let me show that in the code memory. Let me go to long-term memory. So say you talked about the categorization, right?
Yeah.
Um, it groups say everything need to be in system prompt. Okay, so let me take about the memory, long-term memory. So long-term memory could be preference or fact or instruction. So you save it in a categorization, then you pull that from the categorization grouping, and in the system prompt you say, okay, these are the preferences which are saved in the long-term memory, and these are the facts which are saved and grouped into the database. These are the instructions, so that it gets clearly, okay, what are the preferences, what are the facts, and what are the instructions. So grouping and giving to the LLM system prompt, which always guide the LLM to take the right reasoning and decisioning.
Yeah, this sounds like a cheat sheet for me that Claude reads before every conversation, right?
Yeah, yeah, exactly. So similarly for long-term memory, episodic memory, or everything, if you give in a characterized way as a cheat sheet, as you mentioned, then it can take the right decisioning, which will avoid the hallucination, basically.
Yeah. So does it pull out the questions that were asked and which tools we used before? Because that will really give a quick recap to Claude to understand our preferences and context, right?
Correct. So now the three memories, right? So all of that will be pulled in and it will be stitched. Okay. Now I'll go back to the main agentic core. If you see here, okay, so now we are retrieving all the memories. So, okay, where is that? Yeah, here. So now we are talking about the memories, right? So it is pulling all the memories and it gives a memory context. So it gives the short-term memory, and short-term memory is nothing but the current conversation, and long-term memory grouped into preferences, facts, and instruction. And episodic memory is the previous chat conversation, gist, summary, etc. So all of that will be useful when you make a call as a cheat sheet to take the right reasoning and decisioning and action.
Yeah, that completely makes sense. So as we go through this flow, no, I can completely relate to what we saw in the full big picture in the last episode, right? So we are going towards the tool, we explored the memory, and now I'm very keen about the system prompt. I feel like that's the secret sauce for an AI agent. No, can we just look at it how it is built?
Yeah, that's my favorite part, and also that is the important part of AI agent, which is the DNA of AI agent. So let me open the code. Yeah, so this is the code. And I'll just start from the linking. So we talked about memory and that agentic chat flow. So it's calling the build system prompt, which is here. So which is coming to this prompt, builder prompt, builder.ts, build system prompt. Okay. So now let me explain a few things. Okay. So now, so this is the detail. So basically you need to tell, okay, what is the role of the agent? You are a helpful professional proactive agent. You need to read and manage email, calendar, documents, etc. Remember important information. Then it exposes the cap. Yeah.
It literally looks like a job description for AI.
Exactly. So first you need to get that right. What is the role of the agent? That is the job description of the agent. After that, you need to expose the capabilities. Okay. So now you need to give the capabilities one by one, and you need to make it dynamic. For example, you can keep that something or static, which is general behavioral guidelines. You need to be concise. What are the tools available? Emails, calendar, documents, and something will be dynamic. So you need to give certain rules for Gmail specific, certain rules for calendar specific. If calendar feature is enabled, give the prompt. Okay, this is where you asked one question. If you want to specify check before sending email, you can specify it here.
So the guardrails comes here. Okay, got it now.
Yeah.
Got it. That's amazing. The system prompt is like a living document that actually adapts to the user setup, right? So a lot of characteristics, the behavioral and the dynamic changes are all being set here.
Exactly. At the end, we inject a user memory context and reset conversation history when the Claude reads full prompt. So this is the parts of construction of the prompt that you send it to LLM. Then it knows, okay, who it is based on the role description, what it can do by reading the capabilities and tools, etc., using the behavioral guidelines. Okay, whether it is general behavior guidelines or specific behavioral guidelines, and what user likes based on the preferences, etc., and what was discussed recently through episodic memory.
That's really, really well thought out. I can feel the prompt is basically kind of doing a lot of heavy lifting here. That is why it is more important, the system prompting, right?
Correct. So in my experience of building agents, the 80% of agent quality comes from prompt engineering and the context engineering. So the code patterns are important. Well-crafted system prompt is what separates out a mediocre agent from a great one.
That makes a lot of sense. Okay, so we've been looking at the client side agent code, but from my experience in production, things work a bit differently, right?
We deep dived into the code of agent, looking at different components. So let's talk about how it works in production. In production, there will be two components. Okay, one is the backend. First, we'll touch upon the backend. So here, if you see the code base, the functions. Okay, this is the backend code. So that will run as a cloud functions in Firebase or whichever cloud that you want to put it, which will expose the chat endpoint, which can be called by the front end. So this will expose the chat endpoint, which will be called by the user interface. So that will take the user prompt and then do all of that we discussed. And it will verify the authentication, is it authorized user, and then it will load the configuration of that particular user for the memory, etc. It will initialize the cloud client, and then it will build the tools, and then it will build the system prompt and execute the as we discussed.
So the pattern is kind of same, right? But now it's kind of wrapped in an authentication and database persistence, is it?
Exactly. So now, in the production, you need to check user is authenticated, database persistence, exactly. And also you need to keep some, say, when we explained first, we did not show the limit in the agentic loop, right? You can also put a limit as a safety loop, so that you don't run into infinite loop in the agentic loop. So if the tools and it's not resolved within 10 times of iteration, then you come out of it and summarize it. So ideally 10 is a good number. Most of the action can be resolved within the 10 iteration of agentic loop. That's so you need to have certain checks in the production.
Definitely, that is an important check to have rather than letting the AI agent to get into an infinite loop, right? So what about the actual Google API calls? How does the agent actually read?
Yeah, let me show you that. Okay, so all of that is here. Okay, so I'll pick up one example. Okay, list email, which is needed for reading. If I want to check, okay, what are the conversation? Is there any email from Srija? So then it will call, okay, the AI will decide, okay, I need to use the read email, and then it will come to this particular function of the code. It uses the Google API call to get the messages, and it's all integrated. So it is getting the authorization token, and it is sending the token and the API, which is kind of configured when the user starts using this personal assistant, and it gets that messages by calling the Google API. You can call API directly, or you can use MCP server and tools.
Got it. So it's just a standard REST API calls to Google's API and using an authentication access token, right?
Exactly. So this part is nothing magical. The magic happens in the orchestration, and the cloud decides when to make these calls, what to do with the results, and the API calls themselves are straightforward API calls or MCP and tools if you want to use.
And how does this authorization token get there in the first place?
Yeah, so that is a good question. Say now that is very important also. So when you cannot let read the email without the consent from the user. So in the application, you need to have a configuration. So when user click Google, in this case, it's a connect to Gmail, you need to have a configuration. So when user click connect to Gmail in settings page, it will redirect them to Google Auth Connect screen, where user gives a consent and give authorization for read email and write email. At that time, the authorization tokens will be retrieved from the Google Auth, and it will be securely stored in Firebase database, which is retrieved here and used for authenticating.
Okay, so everything happens in the backend. Good. So we spoke a lot about this backend. I want to know a little bit about the user experience. So what does the chat interface will look like?
Yeah, so let me open the front-end code. So the front-end code is there in SRC and app. So that app has a chat component and page. You will have only conversational interface. Nowadays, I think many of the AI application is starting with a conversational interface. Basically, the user will give user prompt only. So it will get that user prompt. And then it will call the API in the backend, which we just talked about, the chat API. And it will send that message. Okay, now here is the API chat, and it will post that user message. And then what is the conversation ID? What are the recent messages, 10 messages? And then all the magic happens, that agentic core happens in the backend. And it will get back the message to display back as a response.
So basically the UI is just a wrapper where the user can put the message in and everything happens at the backend and just the interface happens to this UI screen. And we have all the capability to change the colors, the format, the design that we want in this area of it.
Exactly. So it will have login page and other components and configuration setting, etc. All of this code is there in the repo. User front end is very light because all the agentic things happen in the backend.
Yeah. So thank you, Rafi. So we've been able to dissect it part by part, like tools separately, memory, system prompt, the front end, the back end, and all. So now let's take a step back. Can you walk me through what happens end to end when I type something like, what meeting do I have tomorrow to the cloud or the agent?
Okay, let's summarize. When you type, say, what are the meetings do I have, right, in the user interface as a user prompt? So the chat interface in the React, when you hit enter, so the front end takes that message and then sends that message to API chat, which is the backend endpoint, the main endpoint, with the message, which is user prompt and the conversational ID, so that it can correlate, and lost 10 messages in the conversation. So now all of that goes to backend. Now cloud function gets kicked in. So it receives that message and verifies your auth token. Okay, are you authorized to do action? Then it loads your config from the Firebase for the memory, your long-term memory, episodic memory, and then it builds the system prompt. Okay, what you passed is only user prompt. So now it need to build the system prompt. You remember the role, the job description of AI, the capabilities, the behavior rules, your preference that you got from the database, long-term memory and episodic memory and recent chat in a conversation, etc. All of that assembled into one prompt. So that is main part. Once that is done, then it will look at all the tools that are registered. Okay, am I subscribed to Google Calendar, email, what tools to be used? All the tool definitions will be passed on.
Okay.
After when all of this ready, then it will call the first API call to the cloud. That is the first LLM call. Then the first API call will tell, okay, I stopped. Now I need to call a tool. So with a stop reason tool use, which tool you want to call, list calendar events, because you want to know about meetings. So then it will go into agentic loop. So now it will first execute this tool and it will get the result, and then it will pause that results. If you have 3 meetings tomorrow, team stand up at 9 and one-to-one call with one of your team member and a project review later in the afternoon, it will send all these meetings and then make another LLM call. So it will keep going in a loop. For example, if you want to have a project review, you need to know project document. Then you may tell, okay, I want to use another tool to retrieve project document from the Google Drive. So it will call that tool. The loop will keep going on until it says I am done with calling tools or iteration limit is reached 10 times. Then it will send all the tool response and one more time to summarize it.
Oh,
that is the final call. So multiple API call will be happening.
got
Whether
it.
it is tool call or analyzing the tool result, etc. Final summarizations will be done, and that will be sent back to the UI, which will be seen by the user.
It's like a lot of steps. Let me just summarize it once more. So initially you are sending it to the front end, and the front end send it back to the cloud function. Then the system prompt gets built. Then the tools are registered. Then the API, first Cloud API call will be done and the loop gets executed. Then tool execution happens. The result will be sent back to the cloud and the cloud generates the response and it flows back to the UI, right?
Exactly,
And all of this will happen in a couple of seconds, just like
yes,
that.
Exactly.
That's so
So it
fast.
thinks and acts and it calls some tool to do certain function, but all of that will get completed in 2 seconds.
And the user will just see a very clean chat message on the screen. They don't even know about what kind of complexity happens at the backend.
Yep, that's the whole point. The complexity is in the backend. The user experience is simple, which is a conversational interface.
That's so intriguing. All right, Rafi. So let's look at some of the pro tips what we have learned today. If someone wants to build their own AI agent, what are the essential patterns they should know about?
Yeah, I would say there are 5 key patterns. So number one, it's a agentic loop. So your agent calls your agent calls the LLM, and LLM might request some tools. So you execute the tools, sends the result back, and loop until you get the final answer. So that the loop is very important. The agentic loops. So that makes a huge difference. The number two is a dynamic tool registration. So we know it's a non-deterministic system, so you need to enable all the capabilities to dynamic tools. So eventually, say here we exposed maybe a handful of tools, less than 10, but in a production grade, you will have 1,000 tools. So AI can decide which tool to use when. So you need to enable the integration right and also authentication for the right tool. So you cannot go and read some data from some system. So when you enable the tool, authorization should be there. Both forms the integration. Number three is memory system. You need to have short-term memory for current conversation, long-term memory for user identity and preference, and episodic memory for historical memory. So you need all of them. Okay. Number four is dynamic system prompts. So some of the system prompt can be static, and part of the system prompt need to be dynamic. So it should be built based on the user context and what rules, behavior rules to apply. For Gmail, you need to put different behavioral rules. Gmail, you can say check before sending. A calendar, you can say, okay, check the conflicts before scheduling a meeting. So the prompt is a living document. Okay. The last one, which is not the least, you need to keep a transparency, show the user what tools were used, build a trust by being transparent so that the adoption of AI agents by the users will be more trustable, what data is retrieved by using which tool, so that they know who has access to what data and when.
Yeah, that makes a lot of sense. So you see these 5 patterns as an important thing, right? And for the tech stack, Rafi, what would you recommend for someone who's starting out?
Yeah, start simple. Don't make too complex. So TypeScript is a good language for both front end and back end. And there are many agent SDK. So you go with one, I would suggest start with Anthropic SDK and any database for persisting the conversation or preference, the memory, etc. So then you can start thinking about deploying into cloud functions, etc. Build the agentic loop first and the tool second and add memory third, then worry about deployment. All the code from today's episode is in our GitHub repo. The link is in the description. And if you have any question, you can put it in the comments. We are happy to help.
That really helps. So I was able to relate to the diagram that we saw in the last episode and to the code structure that we had today. So I can't wait to tell our audience what will be our next episode.
Yeah, so this is the second episode in this series, AI agents demystified. So first we looked at what is the autonomy of AI agent. Second, in this episode, we kind of deep dived into the code base. How does it look like in the code, right, in reality, with a practical project, which is also shared as a repository. So the next episode, say in this episode, you may be already wondering, do I need to write all of this? In the next episode, we are going to bust all of that. What does it mean? How can I generate whatever I shown today with AI? So instead of writing line by line, so in the next episode, we are going to see how can we generate all of this instead of writing manually.
And so we don't have to write all the codes that you're showing in the screen, right? All the black and color. That was kind of terrifying for me. So that means we can build AI with AI, right? That really will help a lot of people, everyone, including me, to build AI better. And I can't wait to see that magic happen. Thank you so much, Rafi, for the insights that you have showed today. And thank you, viewers, for watching our episode. I am hope to see you all in episode 3.
Yep. Thank you. See you in next episode. Happy building.